I guess many people in the audience know Gerrit Meijer as the PI of trade, but in fact, Gerrit runs quite a big research group, and what we focus on in particular. And now I hope it will switch to the next slide. It did so just a few seconds ago. Yeah, shall I try again?
Yeah.
Yeah, it works. Good. So we do a lot of research on colorectal cancer. And, well, as you know, colorectal cancer is one of the major health problems in the world. And if you look at as a medical doctor who treats patients to the disease, and basically you look, for instance, at the stage of disease at diagnosis, knowing that when the disease is diagnosed early, there's quite a big chance of survival after 5 years. But when diagnosed at late stage, then chances decrease tremendously. Now, the perspective from the pathologist is more looking at the tissues, looking at the transition from normal colon to benign lesions, progressive lesions, malignant lesions that ultimately start to metastasize to lymph nodes and other organs. And looking at the perspective from the molecular biologist, it's looking at molecular alterations like activation of the Wnt signaling, kicking in of genomic instability in 1 out of 2 flavors, and looking at all these molecular alterations that take place. So basically, when you look at the key clinical needs for, in this case, colorectal cancer, but in fact for many diseases, then what we are looking for is for better ways for early diagnosis, trying to find diagnostic biomarkers, better ways to predict recurrence, to allow to determine who should and who should not receive treatment, so looking for prognostic biomarkers. Then if you decide that patients should be treated, you'd like to know how they should be treated, so we're looking for predictive biomarkers, and during treatment, basically you would like to follow the patient in time, making use of disease monitoring biomarkers. So I guess this goes for colorectal cancer, it goes basically for many diseases. So in the end, what it's about is that the clinical behavior of the patient, underlying to that is tumor biology and molecular alterations. And this basically goes back to the scheme that Gerrit already showed you on the very first slides of this meeting. And that is that what it's all about is how can we improve patient outcome. We have to do that by collecting clinical information, by understanding disease biology, and to integrate this. So how are we doing that in practice? Basically, it means that we collect patient information. We collect tumor tissue, blood, and stool. I guess we have the most expensive stool collection of Europe in our group. We make use of preclinical models, like the culture of organoids. And then we do quite some hocus pocus in terms of DNA, RNA, and protein profiling, right? So in the end, we do this profiling, we come up with biomarkers, and that's quite cool. But more importantly, what we actually try to do is to translate the molecular knowledge into clinical tests. And this is not so much a hollow phrase, this is actually a tremendous effort, as you know. Biomarker identification up here, that's the start in the lab of the research. But you do that because in the end, you want to end up with something in the clinic, some kind of molecular test that actually is to the benefit of the patient. So I guess most scientists, a lot of scientists do biomarker research, and then you can publish your great findings. And I guess there's 2 strategies. And one is a kind of wait and see policy. Look at my beautiful paper. You know, many people must pick this up, right? And industry will use my information to actually get this road running and end up here. But I can tell you in the far majority of papers, that's exactly not the way that it works. And I guess most of you know that. So the alternative approach is actually that if you know you want to end up here, to start walking this road yourself. And this is, of course, a very long and laborious and tedious road. There's a lot of steps to take. Biomarker validation means that you need to have access to large sample collections. So you need to have proper biobanks. Assays that you're not used to do in your own lab, you need to come up with public-private partnerships to make sure that actually the right assays can be developed. You need to go through prospective validation and a lot of paperwork to get things organized. You need to make sure that you actually show that your biomarker have added value. So you need to go through cost-effectiveness studies. And then you need to do clinical trials to really prove the point. And then you end up there. So that's clearly a lot of effort that needs to be taken that you cannot do alone. This is really a multi-center, joint, academic and private translational research environment that takes a lot of efforts. And I don't need to convince you that this is all accompanied by the fact that we need a sustainable IT platform to actually query, view, analyze data to get this road working, right? So I guess this is actually the birth of the TRADE project, because in the Netherlands a lot of projects were funded by CTMM. Each of these projects had a size of about 20 million euros, and each of these projects basically have to walk this road, but suffered from the lack of really good IT solutions. And that's why Gerrit took the initiative to start TRADE. Now, one of the aspects of TRADE is that it follows a process-oriented approach. And what do we mean by that? That is actually that we follow the process as much as possible, how things are organized in the clinic, and you try to connect your translational research to that. So patients enter the clinic, there are some standard clinical procedures, maybe blood samples are being taken. And that means that clinical information that ends up in electronic health records should end up in your research environment as pseudonymized data. That the CT scans, MRI scans, but also digital pathology slides should be archived and accessible in an image database. The samples, blood, stool, tissue samples should be stored in a nice way and should be able to find out where can I find what kind of samples. So the biobanking system should be accurate. And of course, as a wet lab scientist, you would like to have access to these samples, select the right samples for the right questions, isolate DNA, RNA, protein, metabolites, do the hocus pocus, and then end up with integration of your clinical and other information with your experimental data. You'd like to spike that with external data for validation purposes, etc. Do your downstream analysis, end up with your papers, end up with IP, improved healthcare, and actually, as we just saw from the great presentation from Bas Bloem, get the patients interacted as well. So, of course, we could have gone to companies like IBM and asked for building them a system that would work, but there are so many tools that are already around, and it's important to actually make use of the tools that are available now. So we did want to avoid reinventing wheel by adopting tools that existed, were needed to adapt these tools, and only if necessary to get towards development of new tools. So basically this is the cockpit of the Porsche that we want to drive. You saw the picture this morning, but for our purposes it looks like in the clinical arena, making use of tools like Open Clinica, or in the clinical imaging arena of NBIA and IXNet, digital pathology, TAPIS, and in the experimental domain of tools like the phenotype database, from which you will hear more about later on this morning, and Galaxy. And guess what? What do we use for data integration? Of course, we make use of tranSMART. The tranSMART tool, the central tool here, is really the key tool to make this all work. The data integration tool, I think, is the most important of all. If I have to summarize all the tools that are upstream of tranSMART, I would argue, well, we have to work towards fair data and Smurf pipelines, because if we do that, then actually we have the best approach to make the data findable, accessible, interoperable, reusable, and actually also to trace back how we did our molecular analysis. And then there is an important aspect in the trade project that actually is one of the key reasons that I got involved, and that is that there's a user-driven priority setting. I'm not an IT person, I'm a molecular biologist. So, yeah, what does it mean, the user-driven priority setting? It means that you want to look at when are users actually satisfied with the tools that are being developed, when will they actually use it? So the question is, what is it that users want? And the answer is simple, they want the holy grail, right? The data integration tool should really connect the clinical information and the disease biology information. And so what the software developers developed is tranSMART. And the question that I want to address today is tranSMART indeed the holy grail for the users? So let's see. Let's just take one of the studies that we have been doing in the DECODE project, which is one of those CTMM projects, and this one led by Gerrit on colorectal cancer. And in one of those projects, we wondered about biomarkers for patients who underwent surgery of metastasis in the liver. And the first step we took is that we went to the PALGA database, which is already a unique database in the world, which allowed us to ask the question, where in the Netherlands have people undergone surgical resection of liver metastasis? And the answer was, well, in a number of hospitals, among which these. So we immediately knew where to go and ask the surgeons about medical records of more than 500 patients. And the pathologist, we asked him for more than, for all of these patients, from paraffin blocks, from the metastasis, and if possible from the primary tumor, etc. And then we made use of these paraffin blocks to generate tissue microarrays. So you just punch out cores from these individual blocks from individual patients, and so you can collect a lot of tissue material from a lot of different patients on single slides. You can stain them, as you see here, by an H&E stain section. So here you get an overview of the course of many different patients. But more importantly, you can stain them for your candidate biomarkers by immunohistochemistry. So the more brown it is, the more expression of your candidate biomarker is present. So when a pathologist looks at these cores, you can see if there's little brown or no brown, there's negative or weak, and if it's more brown, more or high expression of your candidate biomarker. And then the only thing you need to do is to discriminate low expression from high expression and wonder whether that has any effect on the overall survival of these patients. And in this example for aurora kinase A, you can see that indeed there's a nice difference in prognosis if you compare the patients with high and low expression. So the PhD student that did this work, I think he left this weekend to Australia for his postdoc. And that gives me a bit of a challenge because he has collected all this data. And I actually, would like to keep on continuing to make use of these data and combining this one expression for one biomarker to another one, make sub-selections based on patients with KRAS mutations or BRAF mutations. So it's important to capture the data from these studies. And so we try to do that. And maybe you have seen his poster, which has been around, a poster from Jeroen Goos and Nicholas Tetonicus, who's actually responsible for the TEPIS part, Mariska Bierkens. So what we did is we captured the clinical information in OpenClinica. The cores from the tissue microarrays are exported to TEPIS, and the scores of the individual cores are collected in the phenotype database. And from these tools, the final scores, the final data are pushed into tranSMART. And when using tranSMART, you actually get to see back the links to where the original information is there. So if you from tranSMART would like to see how do actually the cores of this subgroup of patients look like, you should be able to go back and find those cores. So, well, in tranSMART, we are now in a test version entering all these immunohistochemical stainings, working towards reproducing these survival curves. And this is an example of how you can come from the metadata in tranSMART, linking back to these images in TEPIS. And you can link back to the actual information about how the assays were done. What kind of antibody did you use? What kind of algorithm did you use to decide what is low or what is high expression? And this will be also come back in the later presentation by Hilda Bouwman and Mariska Bierkens. So looking at the cockpit again with tranSMART as the central tool, you actually saw that we connected to OpenClinica, TEPIS, and the phenotype database. But in fact, in the molecular profiling domain, there's many more examples where we connect also to Galaxy, Chipster, and you have seen maybe the poster on the cell line use case. There's a lot of different data types that we now can accommodate in tranSMART, so including next-gen sequencing data, array data, etc. And also to actually visualize these data in a genome browser way in tranSMART. So what I would say is that in the past years, within the TRADE project, with the excellent help of the developers, in particular from the Hive, but also from Philips, we actually were able to accommodate a lot of the data types that we generate in our project. And that is really fantastic. So tranSMART gained a lot of functionality for our purposes. But you feel right what's coming now, right? However, there's, in the Netherlands we always say maar, there's our however. However, from the perspective of the user, tranSMART is at this moment, I think, still hardly used. So you cannot be satisfied with tranSMART as it is, with just gaining the functionality. It really needs to be used to be a success. So what's the problem? So in the TRADE project, there's a lot of emphasis on the professional support and training. So let's have a look whether this domain within TRADE is actually working. And the answer is yes, it's working. One of the tools that has been adopted and that is actually quite ready to use from the beginning of the project is OpenClinica. And as you can see, when the years passed, this is the number of studies that make use of OpenClinica. And the number of users is a multifold of that. I think for OpenClinica, it's around 1,000 users at this moment, just from people who knocked on the door of TRADE and started to adopt this tool for their work. And I think this is the curve of tranSMART, and that is, well, that's the way it is, but I'm kind of jealous looking at OpenClinica, and I really, really, really want the curve from tranSMART to, from this point on, start to get this uptake and then go parallel with the OpenClinica curve in terms of the number of users in the Netherlands who really start to use tranSMART. So what is one of the problems? One of the problems is, okay, how are you going to attract tranSMART users? And to my relief, actually, a lot of the items that I want to bring in already have been discussed in this meeting quite a lot. So I'm actually happy to see in this meeting that these issues already are being addressed by the community. But just let's go through anyway. So one key topic is, well, data loading. Where do I begin? So in the trade project, we realized that we should actually put together a data team. And a data team means that we need someone who understands the studies and the IT people, so we need some kind of a data consultant. We have a power user, Mariska Bierkens, where are you? There are you, and you're also like the typical person to be the data consultant. And that actually brings together that you go to the studies, go to someone who actually understands what was done in the study, the data supplier, and that you connect to someone who understands how you actually get your data into tranSMART. So at the Hive case has now working a number of, how do you name them, data scientists? People that are really capable of bringing your data into the tranSMART tooling. So this is what we started recently, and I think in this iteration of this kind of putting these disciplines together to really speed up the process. And that will bring the data to the study owners, to the users that like to query their data. It will also bring us to the learning curve of how to do this for each individual data type. And this is where I think it's also important to work towards documentation of how you actually do that. So if you have done it once for a certain data type, you know, you can do it 10,000 more times. That shouldn't be really difficult. So looking again at the cockpit of the trade project, getting to the overlay of all these tools, well, basically these tools were already meant to do quite some of the data curation, to try to work towards fair data Smurf pipelines, to connect these tools to tranSMART. And so going through this process of data loading, I hope we can achieve a point that we at least get to a semi-automated upload of data into tranSMART. Limited effort, you will always need some additional people who are experts in doing that, but you can streamline the process. Another aspect is how user-friendly is tranSMART when you open it. And you get, you know, when you open it, you get this beautiful tree, right? But this tree is a bit of sometimes too impressive. It's like you cannot see the wood for the trees, right? So if I open a tool and I'm, you know, one of those lazy users, what I would like to see is, you know, these trees are really inviting, right? And actually you can see that they are useful because they really already accommodate me to actually sit there and to query through my studies in a way that I would like to do that. Listening yesterday evening to the presentation by Paul Avelak, I could imagine that I2B2 might be of help to the users to really feel a little bit more comfortable in this tree and to really be able to query the studies in the way that different users might want to do that. Last but not least, and already also discussed quite a lot during this meeting, is that, of course, the user interface is important. And it's really nice to see the amount of attention that the tool SMART-R has gotten for good reasons. I'm very enthusiastic about the possibilities that were shown for the SMART-R tool. Yesterday, Jan Hudacek and Peter Kok have been discussing the CBio portal, which I think is also a great tool to work with. And the example that I keep on mentioning is that the one time that I came back from a meeting and showed to my molecular biologist colleagues the tool CBio portal, that's the one time that after seeing that tool, they actually started using it themselves. They were immediately enthusiastic. What you need to do is very intuitive. You already have some studies there. You can do some queries. They like the layout. And that's the way that tranSMART should become as well. Just open it and then people get addicted to it because it's so nice. So here are some screenshots of the CBio portal and actually how you might be able to push data from tranSMART in the bio portal. Yesterday, Peter Kok also demonstrated the OncoPrint, which has been redubbed GenePrint because tranSMART offers more than cancer studies, and I think the GenePrint is also suitable to accommodate basically any study. So Let's get to the bottom line. How to attract tranSMART users? Well, facilitate the users. Improve the loading of the study data. Improve intuitive data querying. Improve data visualization and data analysis. And the one thing that I really appreciate about this meeting is that most of these topics, well, all of these topics have been named explicitly, and I think they are high on the priority list to be further improved in the next version of tranSMART. And I really hope that that will be done. I realize that I'm presenting this to an audience that is full of developers, so maybe this slide is actually even more intuitive to you, meaning, okay, IT just works, and you know this guy, and you know what this guy achieved. So I would say the success of tranSMART is not about IT. The success, in the end, the real success of tranSMART is about the fact that it's being used by users. I emphasize, Keith, users, because the customers will be very happy when there are users. So there is a difference between users and customers.
Steve didn't have any users.
Sorry?
Steve didn't have any users.
He has a lot of users now, right? He has a lot of users, and they are willing to pay. So that's the thing. First, you need to provide something that people like, and then they're willing to pay. And I think if I talk about the Dutch landscape, and if I have to convince my colleagues about using research IT tools, they are still very allergic to it. In the field of molecular biology, you know, people are not used to it. It's like I have to teach them to brush their teeth. It's like something you need to do to be proud of your own research, to sustain your data for the future. And people don't realize yet. So don't ask them to pay yet. Just offer them a toothbrush and some toothpaste, and they will get started. And then you can ask them to pay. So this is the bottom line. This is the take-home message. One final remark is that I'm not going to acknowledge all the people involved because there's way too many, but I will mention Mariska Bierkens, the power user in the project, and the link between the users and the developers. So thank you, Mariska, and thank you for your attention.
Thank you, Raymond. So, question?
Thanks, Ramon. It's really nice to have this kind of all crystallized. We could have probably just watched this and skipped a couple of days of other presentations. But I will say, you know, we tend to talk about user interface. If you broaden it a bit to really focus on user experience, then I think we do have to pay attention to the IT, because there's a lot of IT effort that goes into a good user experience. And, you know, Steve Jobs paid a lot of attention to the hardware design and that sort of thing to get that user interface sort of elevated from just a nice interface to a nice experience. So I think maybe user experience is you know, the more inclusive term.
Okay.
You're just saying it comes from a user's perspective, and that if you do, then they'll use it.
Yeah.
And then IT do what you, the user, tell them that they need to do it. Rather than IT building it.
Exactly.
I have a quick question, Ramon. It's a great talk, and I think you form a lot of issues for us to think about very seriously. One of my questions is, looking at the Open Clinica adoption curve, which is a very attractive curve, comes back to this question of who's using the platform. So who uses the Open Clinica platform? Are those clinical scientists, clinicians? Who are those people that are adopting?
I'm looking whether Marianelle is in the room, actually, or maybe she's in the other. Do you want to comment, Jan Willem?
Yeah, maybe I should take that one.
Yeah.
Can you hear me? Yeah, so when you look at it, mostly investigator-driven studies. So clinical investigators that hire a postdoc or a PhD student, setting up relatively simple retrospective studies, that they want to manage themselves. They don't have the money and to hire people to do the data management. And Open Clinica is really the do-it-yourself tool for that.
And are they using it more in data entry or in data recall? And do you know what the mix is?
Yeah, so it's really a data entry tool. So it's a controlled data entry tool. So you have all the controls like audit trails and things like that, but it's a data entry tool. It's not a data analysis tool. So typically, when you have complex studies, you need a tool like tranSMART, certainly when there is a genomics component attached to it. When you have only clinical data, typically tools like SPSS are used to do the analysis.
Okay. It seems to me that certainly those customers, if they're putting data in Open Clinica that's going in tranSMART, those are part of your tranSMART adopters.
Oh, absolutely.
That are,
absolutely. So, in my opinion, looking at the Open Clinica curve, I think, well, those people in the end want more than just the clinical data. So their data can be transferred to tranSMART, and we have made, I think, the link between Open Clinica and tranSMART to get this done semi-automated. And those same users then will be able to actually connect the clinical information to whatever other data that they have collected.
So on the small part of your curve there, who are the adopters of tranSMART? Who are those people?
Well, me for a starter.
Are these clinicians? Are these translational scientists?
I think any of the people who want to ask the questions across one domain, and with a domain I mean either clinical or imaging or the biobanking or the molecular. So the moment you want to combine any of these questions, so that will be the PIs of translational research projects, it will be their PhD students and postdocs in the group. And they come in different disciplines because in our group we have medical doctors, we have molecular biologists, we have bioinformaticians. They all will work with tranSMART to go for the same kind of translational research questions.
So,
we have a similar project in physicians and nurses that are going to be using
I think one of the things that we always have to think about when we're looking at the application that we're building, which we're using tranSMART as a platform to build an application, which includes data, tools, interfaces, things of that nature. I like to see adoption curves are, here's the total number of people I expect to use it, and here's the percentage of adoption I have. I think one of the challenges that we have in our community is that there aren't that many translational scientists. And when we go out, and we did a survey this past year of how many institutions have installed tranSMART, how many people are using it, how many people do you expect to use it. And we look across our community, I think it was about 1,500 users were identified across the entire community as numbers of people that use the platform. And I think that's actually a pretty deep penetration of translational scientists because there aren't that many. I think one of the challenges is who is the right end customer? Getting data in, I think when you have an application for getting data into a database, because that's part of your mandate, getting data in is one thing. Having people that can do the synthesis, the analysis, the business analysis, right? I always think of tranSMART as sort of business analytics for biomedical research. That's a small number of people that have that expertise,
yes,
and I think we have to figure out what they're trying to do.
So the Netherlands is well organized, and people like Gerrit and Jan Willem are conquering the field in the Netherlands.
Absolutely.
They are working very hard to actually say, okay, 8 university medical centers. You all hate the fact that when people leave, the data are kind of evaporated in Excel sheets. The Dutch Cancer Society, the Dutch Heart Foundation, and the Dutch equivalent of NIH, they all hate the fact that the data are gone. So they're now putting a lot of pressure on the university medical centers to actually make sure that the data are maintained in a sustainable manner. For the individual PhD student or for the individual postdoc, that's not very attractive. That's just extra work. So I have a challenging job, to convince them to use this. I have to learn them to brush their teeth. That's not a nice task unless I really have some visualizations, etc., to make it attractive. But when this really starts off, then I think in the Netherlands we are able to, starting with the groups who were involved in the CTMM project, so let's say that's like 20 consortia already of public-private partnerships where all the academic centers are involved, where a lot of the translational research community in the Netherlands is involved. So there's a nice landscape to start off with. If we succeed to do that, I think it can grow just like the example that Bas Bloem gave this morning, where he started off in the Nijmegen area and ended up with adoption of the Parkinson Network worldwide. So that's the kind of strategy that I hope that we manage to really get it going like that.
Thanks a lot, Raymond. Okay, so we'll continue this science session.